Good day, ladies and gentlemen. My name is Wei-Xiu Liu. I'm a neurosurgeon in Tri-Service General Hospital and the National Defense Medical Center. My partner is Professor Pingquan Chen. He works in National Taiwan University of Science and Technology. Today, we want to present the topic of application of advanced manufacturing to enhance the quality of clinical neurosurgeon training, creation of lifelike brain simulator. Why do we want to create the lifelike brain simulator? First, the training opportunity of young neurosurgeons decreased. Second, the training in operation room was limited. Third, catheters are limited and expensive. In fact, the neurosurgical training camp are only held twice 1 year in Taiwan. It will make that the young neurosurgeon has less experience to practice the operation. Moreover, one human cadaver head needs more than 100,000 Taiwan dollars. Therefore, we try to resolve the problem by developing the brain simulator. As presented, there are 3 models for neurosurgeon training: cadaver, VR, and 3D printer. As we know, cadaver is very expensive and difficult to acquire. The elastic of brain parenchyma and the cerebrovascular is different from living humans. VR image has no hepatic feedback and it costs much money. 3D printer shows dimensional error of cerebrovascular, poor transparency, and low elastic. Therefore, I have a cooperation with Professor Pingquan Chen to fabricate the solid neurosurgical training simulators with low cost and innovative technology. Characteristics of simulators are simple technique, modulation, and high simulation. The technique of our brain simulator only made by 3 kinds of technique: 3D printing, casting, and replication. Through the brain simulator, the neurosurgeon training can be able to operate in easy way. So the learning intention and effectiveness increase, the human resource cost decrease, the time of learning curve shorten. The most important advantage of our brain simulator is similar to real human brain in clinical. Our brain simulator can provide a new training method instead of cadaver. Furthermore, the brain simulator can assist the medical training to prepare their medical license examination. In the future, combined with electrical sensor, the brain simulator will provide more function and variety of surgical training situation. The next speaker is my partner, Professor Pingquan Chen.
Following Dr. Liu's introduction, then now we understand the need of training the medical interns. So as an engineer, we try to use 3D printing and replication technique to create physical simulators to train those medical interns. So here I'm going to introduce 2 types of simulators. The first one is used for aneurysm surgery practice, and the next one is a simulator used for brain cancer surgery practice. So here we try to use the similar technique to create like a brain cancer embedded inside the brain as a simulator for medical intern to practice. So overall, what the idea behind these 2 simulators is modularity. So what we have built is a common parts plus the functional parts. So in other words, if the students try to practice the surgery on aneurysm practice, then we will use the common part combined with the aneurysm part as a whole simulator for practice. And on the other hand, if the other students, they try to practice on the brain cancer surgery, then they can use the common part combined with the brain cancer functional part as a simulator for practice. So here we demonstrate the function of our simulators. Okay? Then an advantage of our simulators over the other current technology, including that our surgery like the students can practice the surgery, okay, and in the physical simulators. And they can do this craniotomy and also the clipping surgery and also the brain cancer surgery on our physical simulators. So they can feel the real thing and feel the feedback during the surgery practice. So in the end, to the conclusion, the demand of the physical simulators is very emergent, and because it can significantly improve the surgical skill of neurosurgeons and to maintain the high level of safety of patients. And with this novel and scalable fabrication process, these lifelike simulators were fabricated and able to meet the requirement of neurosurgeons training, except only using very expensive cadavers. And more information can be found from our video, which were put on the website. Thank you very much.